Thank you. I'd like to begin this evening with a story and some lessons learned. I'm going back to February 1st of the year 2003. My crew was only 5 weeks from launching into space on the Space Shuttle Atlantis, and our mission was to the International Space Station. We were doing one of the logistics missions, taking up science experiments, 3 crew members, changing out logistics. We were very excited. We'd been working very hard. And that day, February 1st, there was a big event happening. The previous crew was coming back from their flight, and that was the Columbia crew, STS-107. It was a Saturday morning, and I woke up my son, who was 2 years old at the time, about 7:30 in the morning, and I said, "The space shuttle's landing. I'm going to show you what Mom is going to be doing next month." And we were watching the NASA channel, and everything was going fine. The crew did the deorbit burn, and they appeared to be what had been a very successful mission. And then I knew something was wrong when the crew wasn't answering the radio calls from Houston. The CAPCOM was calling, "Houston, comm check. Houston, how do you read?" over and over again, and no answer. I thought, well, that's not normal at that point in the entry. And then I knew something was terribly wrong when the radar controller in Florida said that he did not have a return on Columbia. And I remember how I felt at that moment. I froze. And I knew something was terribly wrong. I started changing channels, and I saw the debris burning across the Texas sky. Columbia was lost, and the first orbiter that had flown in space, and 7 of our friends were lost. And that was a terrible day and the beginning of a terrible time period trying to get the shuttle, recovering from the accident and trying to get the shuttle flying again. There were many lessons learned from this, and I want to share some of those with you today because I think these are lessons that not only apply to the space program, but they apply to everybody and how you do your job every day. If you are on any kind of team, if you sports team or a board or people that work together, there are lessons that apply to your family life and your relationships with other people. And there was just so much to be learned from this. Now, a accident board was put together that very day, and it took them 7 months, and in the course of that time, they determined that the cause of the accident, the technical cause of the accident, was the presence of a hole in the left wing in the heat shield. It was about 4 to 6 inches, they think. No one ever saw a picture of it because the crew never knew it was there because it was actually a little bit underneath the left wing at a place where the crew couldn't see it. So a hole about yay big, and on entry, we heat up to almost 3,000 degrees Fahrenheit outside the shuttle, and that plasma flow got into the wing, it melted the aluminum, and the wing broke off, and that's what technically caused the accident. But what the accident board also said was just as guilty as the technical cause was the organizational and cultural factors that contributed to the accident. And this is what I find very interesting because what they found was factors that I didn't even know existed in my own organization, but things that we're very aware of now when we try to we try to be very sensitive to these things so we can continue to fly safe space missions. So what I'd like to talk about in the next 10 minutes or so is leadership and teamwork in high-risk organizations, in organizations that really take risks, or hopefully something you can apply to your everyday life. Now, and by the way, after that, we're going to have some fun. I brought my video from my last mission, and I'll narrate that. And after that, I'll show you some pictures of the Earth from space that I know you're really going to enjoy. And at the end of my talk, we'll have questions. So as we go along, think of some questions that you might want to ask, and I really love to interact with the audience, so we'll do that at the end. Now, any talk on lessons learned from the Columbia accident wouldn't be complete unless I at least do a little bit of background. I think NASA is a great organization, and we do a lot of things right. And sometimes that isn't highlighted. Usually when we do things wrong, it makes the newspaper. But there's a lot of things we do right. And I think back to when I first joined the military, we were taught three things, the three classic, you could say classic, or the three traditional leadership principles, or principles of leadership or teamwork. And they are, I'm not going to go into this very deep, but I just want to mention, they are knowledge of your job, people, working well with people, and number three, integrity. So knowledge of your job, we know how important that is. Know your job, do your job. Excellence in your job, always working hard, studying. As a space shuttle commander, I know that what I know could save my life someday. So I study. I would memorize procedures. I'm a runner. I'd run those procedures through my head over and over. When I was swimming, I'd run those procedures through my head. I memorized them cold. And no matter how much I learned, there was always more to learn. And I was always trying to be the best at what I could do. And NASA's very well at doing that and motivating coworkers to be the best that you can be. The second one is people, working well with people. Obviously, communicating well, knowing the people that you work with, learning their names, remembering their names, learning their talents and interests outside of their job, learning about their family, learning about any special needs they might have, and really putting the right people in the right job, which sometimes is hard. Make sure that people's talents are in the right place. And I think NASA does that very well. And the third, but not the least, is integrity. And I like to ask school kids, what do you think, in fact, I gave a talk to middle school girls last week, what do you think integrity is? And they almost always answer honesty, which is correct, but it's only part of the answer. And I think integrity, which is very, very important in leadership and on teams, it is honesty and telling the truth. But a leader who has integrity not only tells the truth, but you expect that person to continue to tell the truth in the future, and you trust them in that respect. And integrity is having standards and maintaining them for everybody equally. And also when you make a decision, people don't have to guess, well, why did they make that decision? Why did the leader make that decision? You know that the leader made that decision in the best interest of the team and the best interest of the mission. NASA's always done those things well, knowledge of your job, working well with people, and integrity. So why did this accident happen? Let me give you a little more detail on what had happened after the launch of Columbia. So this was January 16th, 2 weeks before the accident. Very safe, uneventful launch from all appearances. But later that day, the engineers who are responsible for reviewing launch video saw, by the way, not all the video came out, but of the few scenes that did, they saw a piece of foam fall off the fuel tank, the external tank, that big orange fuel tank. It was about this big, weighed less than 2 pounds. 81 seconds after liftoff, it fell off and it hit the wing. And you could sort of see that. It was hard, but it hit the wing and it shattered into millions of pieces. And the engineers said, there might be some damage to the heat shield. I think we ought to take some pictures of Columbia. And they sent a request to the Air Force, hey, whatever you can do, if we can see it, great. If we can't, at least we tried. Get the Air Force's satellites to photograph Columbia. And the Air Force started working on it, but happy to help. Well, when people in other places in NASA heard that this request had gone to the Air Force and it was being worked on, they canceled it. And the pictures were never taken. And we never saw Columbia's heat shield. We'll never know what it looked like. Had we known there was a hole in the wing, I believe, and some people believe, that we could have launched a rescue mission. Now, my orbiter, Atlantis, was already stacked, and it could have been rolled out and launched with the most recent crew that flew that was up to speed, and could have done a rendezvous and a spacewalk to bring the astronauts home. We never would have brought Columbia back, but we could have rescued the astronauts. Some of us believe that could have happened. So the accident board said that was a missed opportunity, along with many other things. And they went on to talk about organizational culture, and I won't get into that too much other than to give you part of their definition. where they said missed opportunities and faults in the organizational culture. What is that? It's the beliefs and practices within an organization that characterizes its functioning. And at the most basic level, it defines the assumptions that we make every day we go to work. Hey, this is the way we do things here. So what happened? Well, hey, we don't ask the Air Force to, they're getting ready to go to war in Iraq, they're busy doing other things. We don't normally do this. And there were some other miscommunications and things that have to do with the way the organization was structured that we didn't get the photos, and that didn't happen. So how can we learn from that? As you read, I've read the report a couple times. It's painful to read, but we need to learn from it. So I have gleaned 3 major, I would say, lessons learned that we get from this Columbia accident. And they are listening, being a better listener. Number 2, humility, being a humble person. And number 3, creativity, being a more creative person. And I'm briefly going to talk about each one of these with some examples. Listening with an open mind, yes, but there's passive listening and there's active listening. Now, passive listening is like you're listening to me right now, and I'm assuming you're listening to me. But there's also active listening where you go out, or if you're the team member or the leader, you go out and you ask people, what do you think of this? Is this a good idea? Is there a better way to do it? I'm listening. Talk to me. I want to know. I care about who you are and what you think because you're an important member of this team. Some of the bosses at NASA do this very well. In fact, I know some that would go into a meeting and say, you're in this meeting and you have to contribute. You can't sit there and say nothing. When the meeting's over, I'm going to call on you if you haven't said anything. And other things that they do that I like to do with my crew, go to factory visits, go out and ask the employees, help us with this problem, help us learn. What can we do better? So that's listening, being an active listener. The other one is very close, and that's humility. Now, I came up in the Air Force, an organization with fighter pilots and test pilots, and there's not a lot of humility in some of these groups, of which I am part, and I'm going to tell you that I have learned these lessons myself. And at NASA, scientists and engineers, and yeah, there's not, but that's not the kind of humility I'm talking about. I'm not talking about being quiet and shy and not speaking up. I'm saying you need to speak up. But what I'm talking about is a confident humility. Being the type of leader or being the type of team member that is confident enough in your own ability that you are willing to listen to what other people have to say. Maybe my way is not always the best. I want to give other people's ideas an equal chance. And no matter how good I am, I can always be better. And I'm going to have this team make me better. And I'm not threatened by anybody else. I feel the teamwork. And a couple of examples. Now, the listening and the humility kind of go together, but let me give you a couple of examples. The first one is when NASA called off the photo request, was everybody really listening? And the second one is something that I heard many people say after the accident. Even if we did take those pictures and we saw that there was damage, there was nothing we could have done. And, well, with the current attitude, there was nothing we could have done. But if you were creative enough to think about, well, maybe there's some possibilities. Maybe we could fly a rescue mission. Maybe we could power down and extend the Columbia flight another couple of weeks. Maybe we could send a crew out and look over the wing and see if there was damage. So there were things that could be done, but you needed to think creatively. So that brings us up to the third point, or the third lesson learned, which is really creativity, which is so important that we stay creative and we encourage the people that we work with to be creative. And I think of two kinds of creativity. There's the daily thinking, thinking creatively every day in everything that you do, and the second one is innovation, where you are assigned a job to be creative, and you go off and do that. So on the daily thinking, what I would try to challenge my crew to do, we'd go in the simulator, or we'd be reviewing procedures for something we're going to do on the flight. Always, always, always ask yourself, is this going to work? Is there a better way to do it? What can go wrong? What can hurt us? Is there a safety issue here? Is this the most efficient way we can do it? Always be thinking, is there a better way? And encourage other people to think that way. Now, maybe a bad example here, and another thing that I heard some of the engineers say about Columbia was foam falling off the external tank. There is no way that foam can damage the heat shield. It's too light. It's like foam in your picnic container, that white foam that you have to keep things cool. There's no way that can damage the heat shield. It's too hard. And people were saying that. But the Columbia Accident Board said, well, wait a minute, it's going pretty fast. It's going like 700 miles an hour. So they set up a test apparatus and they shot a piece of foam at a wing, a test article, wing leading edge, and they blew a hole in it almost the same size as the hole they thought they had on Columbia. And they called it, well, there's the smoking gun. But we weren't creative enough to think or to even expect something like that to happen. So we need to remember these things. The other type of creativity I say is innovation. You're assigned a job, go be creative. Well, we had a lot of, after the accident, there was a lot of go be creative. We needed to figure out a way to inspect our heat shield, and we needed to figure out a way to fix our heat shield in case it was damaged. So a lot of great ideas came out of this. They didn't all work, and we didn't have enough money to fund them all, but we cared enough to ask, please help us do this very difficult job. Now, you're going to see in the video that I show you one great idea, and I wish I thought of it, but it wasn't me. I didn't think of this. In inspecting the heat shield, one of the ideas that came from a smart engineer was when when my mission that I flew after the accident approaches the space station, let's say here's the station, here we come up from below. When we're 600 feet away, flip the shuttle around and expose the heat shield to the crew on the space station. They can take pictures of it with their digital cameras, long lens, zoom in, and downlink those pictures to the ground. And the engineers can look at those and see if there's any damage. And the first things that I heard after this idea came out was, oh, you can't do that. There's a flight rule that says the crew has to keep sight of the space station from 1,500 feet on in. I go, well, we can change the flight rule. We make an exception to the flight rule. And so as people thought about this, you go, wow, this is really a great idea. So we developed a rendezvous procedure, and now every space shuttle that goes to the space station does what we call the RPM, or the rendezvous pitch-around maneuver, and the photos are downlinked, and they give us very good resolution. And there's many other things that we do. We do a robotic inspection with the cameras on the robot arm, but lots of opportunities to be creative and bring out the best in people's ideas and not say, oh, that can't work immediately. Give them a chance. So those are what I would say the 3 lessons learned. I very, very briefly went over them. I could go into a lot more detail, but I think humility, listening, humility, creativity, these are things we can think about in our jobs and our everyday life. They work in very, very high-risk organizations. They are extremely important. I don't care if you work in accounting and finance, or if you work in human spaceflight, or if you want to apply these principles to your family at home. I think they're very good, and they also contribute to a disciplined team. They contribute to a sense of responsibility for the mission, and they contribute to respect each other that we work with. What I'd like to do is kind of move into something a little more light and talk about the mission that we actually flew. We switched to the shuttle Discovery, my crew. Our mission changed very much. Instead of taking up 3 crew members to the space station and leaving them as long duration crew members, we became a crew of 7 shuttle short duration. We flew a 2-week mission with the main goals being testing all of these techniques that we had developed, like repair techniques, inspection techniques, plus resupplying the space station. The 7 crew members I'll introduce to you as I show you the video, but on the space station were 2 crew members. The commander was Sergei Krikalev, a Russian who has a great amount of experience. Back in those days, in fact, still today, the Americans and the Russians alternate the commander of the space station. The science officer at the time was John Phillips. In fact, he's flying on the next mission also. But John is a engineer. He's a geologist, actually. And him and Sergei were really holding the space station down because they had gone for 2.5 years without any logistics from the shuttle. So that's a little bit of background. Let's go ahead and roll the video. And we launched on July 26th of 2005, the first shuttle mission to have flown in 2.5 years. And the world was watching, and they really wanted us to have a successful mission. The crew, we walk out about 4 hours before launch, and we launched about 10 in the morning. We strap in, we lay on our back for about 3 hours. It gets kind of uncomfortable, but you're busy running procedures. Here we are at T-minus 6 seconds, the engines start. Okay, lift off at T-minus 0. We clear the tower there. Actually, we're over 100 miles per hour by the time we clear the tower. Roll program, head out over the Atlantic. On this launch, we had over 100 cameras watching our heat shield and our external tank. Here's one of the cameras on the orange tank looking down. Here's the beach. Okay, here's the launch, the other launch pad. This is the shuttles right here, and here's the wing. And you can see the shadow of our plume. This is a camera on the boosters looking at the external tank. The boosters separate. They separate at 2 minutes and 10 seconds roughly. They fall back. They're retrieved and reused. And just some awesome, never before seen views of the boosters burning out. Fast forwarding here to 8.5 minutes. We have main engine cutoff, or MECO. We separate from the tank. We go up, the tank goes down, and we start our rendezvous with the space station. So we burn our engines, and on the 3rd day of the flight, we dock with station. Okay, this is the rendezvous picture. This is sped up in the video, but this is the maneuver we did. We were over Switzerland at the time, and you can see the beautiful view that there's our landing gear doors right there. There's our main engines. This is a body flap. Okay, view from the shuttle looking at station, solar arrays, living quarters. This is the size of about 5 school buses end to end. Now this is a Soyuz on the bottom and radiator panels. The station looks a lot different than that now because it's about twice the size. Here's the docking, the actual moment of docking. We hand fly the docking from the back station of the shuttle. This is the view that we see. Again, here's the living quarters of the station. About 2 hours later, we open the hatches after we have equalized the pressure. That's Sergei in the light blue on the other side. He grabbed my hand and he pulled me in. It's like, oh, we are so happy to see you. And here's my crew. There's Andy Thomas coming in. He's our Australian aerospace engineer type. John Phillips you see from behind. Sergei Krikalev on the left in the light blue. Wendy Lawrence in the center. She's a naval officer. Jim Kelly coming in the middle is a former F-15 test pilot. John is holding in his hands. I thought they were happy to see us, but John wanted his coffee. So that's the coffee in his hand, and he went the whole mission without coffee until we got there. Andy's in the foreground, Wendy in the back. They're doing the transfer in the U.S. laboratory. It looks very busy in there because of all the cables and cameras and science experiments and computers. We're up to flight day 4, and it's Soichi, our Japanese astronaut, in the middle, and Steve Robinson in the back. Those 2 astronauts did the spacewalk. This is Wendy and Jim at the robotics station. The robot arm is flown with laptop computers and cameras. You can't see it directly, so you need to use the cameras to figure out where it is and what you're doing. On flight day 5, Soichi and Steve suited up. They went out the hatch to do their first spacewalk, which was to repair some broken tiles that we set up on a test bed in the payload bay. And this is, this kind of hard to see this view, but this is the Soichi over here in the airlock on the space station getting some tools. And here's the robot arm, Canada arm. On the second spacewalk, which was flight day 7, here's Soichi on the robot arm, and they were changing out a gyroscope. This is Soichi looking in the mirror. The gyroscope, there's 4 of them on the space station. One of them had failed catastrophically, and the engineers wanted to see what it looked like. So Soichi on the end of the arm, we flew him over on the arm to the space station. They unbolted this gyroscope, which on the ground weighs 600 pounds. But in space, it's weightless. So the way we brought that home is he carried it in his arms for 45 minutes, is what it took to get it from the here it is, this big black device, and here's little Soichi in this big black, and he's like, look, Mom, look how strong I am. And then they also installed a new one, so it took 6 hours to do that. And here he is again with the gyroscope and on the end of the robot arm. By the way, this is our logistics facility, this great big cylinder. It weighs 22,000 pounds on Earth, and weightless in space. Our third spacewalk, this is Steve Robinson, and he is removing a gap filler. This is the shuttle tiles. When we did our pitch-around maneuver, the engineers saw in the pictures these little pieces of cardboard called gap fillers had popped out, and they were afraid on entry that they would heat up more so than maybe it was certified for, so they asked Steve to pull these out. And that red stuff there is the glue that failed on ascent, and he removed 2 of those, and they have since fixed the problem with the glue in the process. This was Steve's view of the shuttle nose and the space station. Okay, the 3 spacewalks are over, and this is just Andy and Steve downlinking a view of these gap fillers to the ground. Flight day 10, we had to say goodbye to our space station crew. So, we're all hugging and all that stuff, and it gets a little silly, but we sign their logbook and we give them gifts, and they give us gifts. Usually it's a t-shirt or something and a baseball hat. We say goodbye, we undock, and we fly around, and now it's our turn to take pictures of, here's their living quarters, their radiators, solar arrays. This is Siberia in the background. And we get about 50, 60 minutes of photography. We're looking for anything that might be out of the ordinary on the outside of the station. Looking out the overhead windows of the shuttle. Just absolutely beautiful views. Here we're doing a burn to help bring us back home. And we're just showing anything that's not strapped down in space is going to hit the wall. So these guys are kind of goofing off. They didn't have much to do that day. I wanted to show my kids how you sleep in space. This is the sleeping bag. You can sleep anywhere. You can sleep in the ceiling if you want. Landing day was flight day 15. You can see how we heat up on the outside. This is an infrared view of the shuttle as we come into Edwards Air Force Base in California. We come down final there about 7 times steeper than a commercial airliner. We're going about twice as fast, and you have no engines, so you have to do it right the first time. You can see how hot our nose is, and you can see our APUs burning in the back. Touchdown about an hour before sunrise. We were so happy to be back after 4 years of training for this mission. And the next scene you're going to see here is our crew as we got out of the shuttle and started walking around underneath. It's very hard to come back to Earth after a mission. You are very wobbly. You feel extremely heavy and you feel wobbly. So when we get off the shuttle and we shake hands with the managers, it looks like we're saying things like, hello, thank you for launching us on this safe mission, which are all good things to say, but we say things like, don't let go of my hand or I'm going to fall over. Because truly it is, especially the longer you're up there, the harder it is to come back. And I've flown 4 missions, and my take on it now is the older I get, the easier it is to go up, because it's real easy to just float around in microgravity, but the harder it is to come down because your heart rate goes up, your blood pressure goes up. When you come back down after a flight, you get the blood rush down to your feet. And not only do you feel heavy, but you have lost your sense of balance. So you don't want to walk under the shuttle and look up at the tiles because you fall over if you do that. So we're doing a lot of work. In fact, the primary purpose of this on the space station right now is to study the human body in space. What changes when we go up? How can we better protect ourselves? Learn now for longer duration flights, for trips back to the moon and someday onto Mars. What are the risks of being in space? Preventing bone loss, protecting ourselves from radiation, and then also coming back to Earth. What are the things that happen to the human body as we come back? So by adding the variable of microgravity, we learn more about ourselves. And that's the primary research that's taking place on station right now. We seem to be doing pretty good on time. I've got a couple of slides I'd like to show you. You saw what living in space was like briefly, the challenges we have of working in microgravity, keeping our bodies secured while we do tasks like fly the robot arm and get in the spacesuit and do science experiments. But one of the greatest things, in fact, I think the greatest thing about going up in space from the human side is looking back at the Earth. And that has always been my favorite part about flying in space. Unfortunately, we're so busy we don't have much time to look out the window. But our crew got an extra day in space because the weather was bad, so we got an extra 2 days, and we took more pictures. But the photos I'm going to show you now are from all 4 of my missions, and there's a few extra in there. But keep in mind, some of them were taken straight down, like what we call a nadir view, with a zoom lens where we can zoom in and see something a little bit closer. So some of them will show the Earth's horizon, which is what it actually looks like, and some of them will be a view that you would see through binoculars or a camera. So let's go to the next. Okay, this was taken on August 1st of 2005. This is somebody said it. It's the Aurora, actually Australis. So this was the southern lights. The way our orbit was, when we were on the southern part of our orbit, it was nighttime. So you can see the Earth's horizon up here, the South Pole's up here somewhere. And what had happened, we saw days and days of these beautiful lights, and you can't see it in this picture, but they went way up. In fact, they went almost up to our altitude, and it looked like we were flying through a fog. So I called Mission Control after a day of this, and I said, what's going on with the sun? These are caught that when the sun interacts with the Earth's magnetic field, you get these beautiful lights. And they said, well, on the scale of 1 to 9, the sun is at a 7. It's very active. So I was concerned, are we protected from the radiation from the sun? We're below the Van Allen belts, which protects us, but we're above most of the Earth's atmosphere. So astronauts are exposed to radiation. It's one of our biggest concerns for long duration flight, and it's a major concern for going back to the moon and onto Mars, that we protect our astronauts from solar particles, that we get very little, we get some notice that they're coming. We get enough notice that the astronauts on the space station can go protect themselves. But when you're on the moon or Mars, we need to design our habitability, our crew quarters, with some kind of protection. Water is the best. A thin layer of water will actually provide a tremendous amount of protection. But it's heavy to launch water. So we have to figure out ways to make water and design that in to protect our astronauts. Because the real concern is if you survive these solar storms, is your increased risk of cancer later in life. Next. This is, anybody want to guess what we're looking at right here? I think we're over here somewhere. This is Florida, and here's the Bahamas, this beautiful blue over here. And we launch from, it's hard to see because of the clouds, but we launch over in here somewhere. But this is Florida and the east coast of the U.S. I like to show this photograph because 2 reasons. First of all, the Earth's atmosphere, which is hard to see up here, but it's very thin. The Earth's atmosphere is like an eggshell on an egg. It is very, very thin. If you think of it this way, okay, the space station's up at 200 some miles. It varies, but we're maybe about 250 miles above the surface of the Earth. Humans can live up to about 3 miles, and then you start running out of oxygen. Airplanes fly up to about 7 or 8 miles, You become an astronaut at 50 miles, and the space station's up at about 200 miles. That's not that far up. Imagine if you were driving from Pensacola to, what's a city about 200 miles away? Tallahassee? Take that distance and go up with it. That's not that far. I mean, we're real close to the surface of the Earth in the shuttle, but that is space. And it gives you an idea of how thin our atmosphere really is. And we live on a sphere with a very thin atmosphere, and it spins, and it is being hurled around the sun, and there's this great big dark universe, cold, dark, airless universe out there with things like meteorites and orbital debris, and it kind of changes your perspective on your everyday life when you think of the universe in this fashion. The other thing I want to say on this slide is the way the space station and the shuttle operate in low Earth orbit. We go around the Earth once every 90 minutes. So you're going in and out of the shadow. So every 45 minutes you'll get a sunrise, and then 45 minutes later a sunset, 45 minutes later sunrise, 45 minutes later sunset, and the sun's going in the window, out the window, and it really messes up your circadian rhythm. And you wonder, okay, is it daytime or night? So you work off your watch, and usually mealtime will help you remember where you are in the day. And even at night when you're trying to sleep, you got the sun coming in the window. So it's kind of an interesting life of an astronaut, and you really see things from a different perspective. Next. This is Hurricane Rita. I tried to find one of Katrina, but I couldn't. I think maybe the orbit, when Katrina went through 3 years ago, I don't know if their orbit was set up to get a photo. But Hurricane Rita, this was taken by John Phillips and Sergei Krikalev on the space station in September of 2005. You've all seen pictures of hurricanes from space, but I like to show this to talk about the psychology of being in space, because John's family back in Houston evacuated along with 90% of the city of Houston. We saw what happened in New Orleans, so like the whole city decides, well, we're getting out of here. So we had this major evacuation, clogged highways and all, and John's up on the space station, and he sees this thing going at Houston, and he's worried about his family. And even after 9/11 happened, there were 2 Americans on the space station after 9/11, 2001, and it brings interesting psychology into the isolation of being in space, where your friends and family at home, where there's some major event, and you are so out of touch with what's going on, and it's tough. So we have people at NASA whose job is to take care of astronauts' health and family. So we have telephone. It's a laptop computer. The astronauts can call anybody. They could call your cell phone right now if they had your phone number. They can call anybody on the Earth, anywhere, anytime. You can't call them because calls going up are filtered, but they can call down. They also get video teleconferences with their family. They get email, internet access. Unlimited is not there yet because of concerns, obviously, but we're working towards that. So really, really trying to help with this, because once we go back to the moon, they're going to be even farther from the Earth, and once we go to Mars, we're talking 6 months to 2 years away, and how long it takes to get signals back and forth. We want to make sure that the astronauts are happy and functioning as human beings. Next. We're going to go a little faster on the remainder of these slides. I'm showing this picture. It's Melville Island, which is north of Australia. Nothing special about Melville Island, but I showed this picture because of the fires. And at any point in time, an astronaut can look at the Earth around the equator. You're probably going to see, if you're looking at land, you're probably going to see fires burning, because countries are clearing their land for many reasons, mostly economic reasons, and you can see this happening, especially, I'll show you later, in some parts of Africa. And our job is not to judge what's happening. Our job is just to photograph it, send it to the scientists, and they will evaluate it and hopefully help countries realize that some of the resources are important to maintain. Next. This is a little beautiful coral reef. There's thousands of these little islands in the Pacific. So we zoomed in on this one with we were doing a coral reef study. This is actually from my 3rd mission, but we did a coral reef study because the scientists say that the health of the coral reefs will help determine the health of the Earth for many reasons, so we photographed some space to help them with their studies. This is called El Dabra Island. We call it Pork Chop Island, but just beautiful. You look at these places, you go, oh, I'd love to go visit there someday. Next, little jewels of the Pacific. This is the Betsy Boca River Delta in Madagascar, and for those of you that, if you're in the back, you may not be able to see it, but up at the top, the water is blue, but down at the bottom, the water is brown. That is because of the erosion that's taking place. Now, on my second flight, we photographed the entire island of Madagascar, because scientists want to study the deforestation that's taking place. Something like, I don't know what the exact number was, but 80-90% has been cleared. And you can see the erosion in the brown water. But just a beautiful island. Next. This is the Coogan crater, which is up in northern Canada. Scientists believe that this was hit by a asteroid, meteorite impact many tens of, possibly hundreds of thousands of years ago, and because there's very little erosion in this cold area, it still left the crater. We know that there's these near-Earth objects. Some of them, sometimes scientists predict, could be on a collision course with Earth. This may never happen in our lifetime times hundreds, but maybe it might. So some scientists believe that we need to develop a way to, if we see something coming at the Earth, we can divert it somehow. You probably can't blow it up, but you can probably divert it and prevent it from hitting the Earth. So it's nice to know that people think about these things, even though they're not very likely to happen. If they did, they could be catastrophic. 300 million years ago, it's theorized that one hit down in the Cancun, Mexico area. Next. Any guesses on this one? We're looking west. North, close. Good guess, but it's actually on the other side of the planet. This is north, this is south, this is India, China, Taklamakan Desert up here, the Himalaya Mountains. And Mount Everest is in there somewhere. Next. How about this one? Right. Somebody said it. This is the Red Sea at the bottom. This is the Mediterranean Sea at the top. So we are looking west. This is the Nile Delta, this dark green area. I don't remember the number, but there's millions of people that live on the Nile Delta, which is a very fertile area. This is the Nile River. This is the Gulf of Suez, the Sinai Peninsula, and the Gulf of Aqaba. If you look right, see this line right here? I have heard astronauts say you can't see borders between countries from space, but in this case you can. Go to the next slide. This is a close-up view of the same area, and some of you in the back may not be able to see it, but down south, here's the border between the country of Israel and Egypt. This is the Sea of Galilee. This is the Jordan River. The Dead Sea at the bottom. By the way, the sea levels in the Dead Sea have been decreasing over the last several decades. It's very, very salty. And you can find Jerusalem by going from the north of the Dead Sea over here, and it's kind of this gray area. And let's see, what else can we see? I love looking at the Middle East from space because it's almost always clear, and you have these beautiful contrasts between the tan, bright deserts and the dark blue sea. You think of all the history that took place over there. Next. This is going to be hard to guess, but it's a close-up view in the same part of the world. But notice how straight this channel is. It's man-made because it's so straight. It's the Suez Canal. Next. This is part of the United States, and this, yeah, somebody said Hawaii, that's correct. And this is Pearl Harbor. Here is what you can see. We zoomed in to get this picture again, so you can't really see this very well with the naked eye from space. This is the Reef runway at Honolulu, and this is Diamond Head down here at the bottom. It's hard to get a picture of Hawaii totally clear. There's always clouds on the east side of Hawaii. Next. This was taken in the winter. You can see all the snow on the ground. Manhattan. Somebody said, this is Manhattan. Here's Central Park. And, of course, Long Island, if you're from Long Island. And the Statue of Liberty is right in here. And this is New Jersey over here. I'm from New York, so I can do that. And the Hudson River, of course. Next. Okay, this is, we took this in the first week in August of 2005. Anybody want to? Great Lakes, yeah, you're looking west. We're looking, this is not, and when you look out of the window of the shuttle, north is not always at the top. It's not like looking at a map, so you got to be able to translate. This is Lake Superior, here's Chicago, Lake Michigan, Lake Huron, Erie, and Ontario, and Detroit is here, roughly, and Niagara Falls is down here at the bottom. It seemed like every day when we had our break time about 3 o'clock in the afternoon, you look out the window and there was the Great Lakes. Just like clockwork. Next. Yeah, we'll look. Okay, United States again, this is Boston, Cape Cod, and here's Rhode Island. And one of these is Nantucket and one is Martha's Vineyard. I can never remember which is which. You look out the window and you go, I want to go visit there someday. Next. This is Greece. Who said that? That was really good. No one ever guesses that. This is Greece, looking east. East over here. Actually, let's go to the next photo. Greece again. But now we're looking west. So here's the Mediterranean Sea. This is the Aegean Sea with Turkey at the bottom. But the city of Athens is over here, and the city of Sparta is over here. And we studied about that in Greek history. And I like to study Greek history. They were explorers. They went out. They took risks. They took chances. They explored all these little islands out here, partly for military, partly for economic, partly because they wanted to know what was there. But they were curious people, and so are we. And like they traveled the seas, we travel in space. Next. This is my last one of the Earth. And we zoomed in. It's Italy, very good. And unfortunately, Rome is off over here, but Mount Vesuvius is, I think it's right in here. And of course, Naples is the city, yes. Next. You can't help but love geography. As an astronaut, we spend a lot of time with atlases and learning about geography. I've got one more short thing to talk about, and then we'll go to questions. So we got a few minutes here. I want to sort of move into my conclusion by talking about what's coming next. Change is coming to NASA. And I remember somebody once told me, well, first of all, I think everybody knows the Space Shuttle will only fly for, I think we've got 9, maybe 10 more missions, fly for a couple more years, and then we'll retire the shuttle. And we're changing. And change sometimes is hard. And I remember one time someone told me that a person's age can be determined by measuring his or her resistance to change, or the amount of pain one feels when encountering a new idea. And I said, well, that's not going to be me. I want to always be the kind of person that can welcome change. And it's going to be tough to say goodbye to the Space Shuttle, but we have to do it because the Space Shuttle is getting old. And the Columbia Accident Board cited the aging of the shuttle and the fact that we need to move on to something new. So what we have coming is, next slide is, I think most of you are a little bit aware of the Constellation program and the Ares 1 launch vehicle. This is a depiction of it with the Orion crew vehicle is on the top. This thing right here is the crew escape system with these little jets. This launch vehicle is designed very much like with the same concept as Apollo. Safer than the shuttle because in the event of a Challenger type accident, there's an escape system. So if there's an explosion, the crew can be pulled away with these rockets can pull the crew away and they can parachute down into the water in the Atlantic Ocean. Also, the heat shield is underneath and the heat shield's protected. So we're hoping that we have a safer launch system. The next couple of slides, you can go to the next one, will show that not only will the Orion vehicle take us to the space station, 6 people to the space station, but it is also being designed to take 4 people to the moon and hopefully onto Mars someday. So we'll go to the next. I'm going to go quickly through these. Next one. This is just a concept of what building research stations on the moon someday. Next. And what I'd like to say, I can answer questions on that if you'd like, but just to summarize, I've talked about some lessons learned from the Columbia accident, which is so near and dear to my heart. As hard as it is to look back, I want to share the lessons learned. Mainly the working together, being good listeners, being humble people when we work, being creative people when we work, thinking about the wonderful things that we've done in the shuttle program and the great possibilities for the future. I'll end with a quote from Robert Goddard, who's known as the father of modern rocketry. He said, "The dreams of yesterday are the realities of today and the hopes for a better tomorrow." So with that, I want to thank you and open it up for questions. And I'm going to come down. Thank you. You're too kind. I'm going to come down here and get a little closer. I think we have a microphone. So, yes, sir. We've got a question up here in the front row. Don't hesitate to ask me anything. Don't ask me easy questions. Ask me something hard.
Dr. Loesch, retired UN. I'd like to hear your comments on the most exciting event in your career as an astronaut.
Oh, the most exciting event in my career as an astronaut?
Yeah.
Probably getting the phone call from NASA telling me that I was hired. I would have to say, and it was interesting the way it happened. I was actually out at the Air Force Test Pilot School, and I was up flying a spin ride in the A-37 where you do like 15, put it out of control and recover. So I was pretty tired that day, and I came back and there was a message, one of those yellow government notepad messages on the board. Major Collins, call Dwayne Ross at NASA. And I go, oh, they want me to call. That's it? It's the astronaut? Did I get in or didn't I? It's like, well, if Dwayne Ross is calling me, he's the administrator, I didn't get in. Because that was the word is, if John Young calls you, famous astronaut John Young, that means you're in. But if Dwayne calls you, you're not in. So I go, well, I didn't expect to get in anyway. That's okay. So I called Dwayne, and he says, hold on for a minute. And he gave me the secretary, and she said, hold on for a minute. And then they gave me one of the board members, hold on for a minute. And then they handed me off to like 5 people. And then they handed me off to the board president, Don Putty. Hold on a minute. Like, what's going on here? These people don't know what they're doing. And then they put John Young on the phone. And he said to me, do you still want to be an astronaut? I said, well, let's see. Since I was 9 years old, I wanted to be an astronaut. I haven't changed my mind, sir. And he said, well, come on down. And it was interesting that I actually interviewed as a mission specialist. And there had never been a woman pilot. But I interviewed as a mission specialist, and that phone call went on for 10 minutes with John Young telling me about all the training to be an astronaut. And at the very end, he said, do you have any questions? I said, oh, am I going to be mission specialist or a pilot? He said, you're going to be our first woman pilot. So that was probably honestly the most exciting. But, of course, the launches were exciting, too. It was all great. And I love opportunities to share the message. Let's see, a question from this gentleman here. Yes, sir?
Good evening, and fascinating to hear you speak. It's wonderful. Thank you. As a former pilot, I'm interested in your 360 rotation, weightless craft heading towards the space station. How did you control the craft in that maneuver, please?
Okay, actually, his question was on controlling the space shuttle in the maneuver, what we call the RPM, the rendezvous pitch-around maneuver. Actually, the hardest part of that maneuver, and what we trained for 2 years, the hardest part was setting up for it. So which is all hand flown. So with the space station up here, you come up you have to hit exactly 600 feet. I think you get plus or minus 5 feet. Hit 600 feet with an x dot, which is your velocity in this direction, of 0.1 foot per second, and your z dot going this way of 0.1 feet per second. So you have and then your y dot has to be 0, so you can't be going out of plane at all. That was the hardest part. You start the maneuver. If you don't hit those points, you have to keep burning fuel until you do hit those points, making inputs, right, left, in, out, up, down, translating. So once you start the maneuver, you put it on autopilot. And the whole thing is flown, the whole maneuver itself is on autopilot. But that was the easy part. The hard part was setting up. And then when you come out of that, you as soon as the maneuver's over, you go back, you hand fly it, and it's hand flown all the way in from there. Now the Russians fly their rendezvous and docking on autopilot. About half the time they take over manually and do a manual, because the autopilot is not really perfected. So someday we'll have better autopilot. In fact, they're designing the Orion will probably be like the Russians do, probably automatic docking. But right now the shuttle is all manual. It's very challenging, but that's why we train so much. Let's see, how about a question over here from a young lady?
Victoria Glass, Air Force Junior ROTC, FL12. I know with being in the Air Force and with NASA, like you said, since you're one of the first women, it's very male-dominated. And he talks about how you have to work together. Did you find it was hard sometimes with the guys to try to get your point across and to do what you wanted to do?
Okay, her question is on working with the guys. I have always, I'm just a team member, and my answer, no, I really can't. I mean, you'll have trouble with certain individuals, but I would never say I had trouble with guys in general. Never. Now, I will tell you some of the things that happened. I remember when I was the first woman in the first class of women at Advanced Air Force Base going through pilot training, and then I was the only woman instructor there for 3 years. The wing commander would always come in, and he was joking, but he'd say, "Good afternoon, gentlemen and lady." And he'd always do it, just kind of, trying to, and I had a sense of humor I would laugh at those things because you need to be a little bit lighthearted. And some people might have taken that offensively, but I would but then there were a few people that thought the women shouldn't be there. And I go, well, I'm not here for them. It's always, always, always go back to the mission. It is so important to go back to the mission. I care about the mission. It is very important. I focus on that, be the best I can be, and the guys support you. So I'd say it's been great. And I've really enjoyed working with the guys. I do wish there were more women, but we need more women to choose these careers. We need more women to choose to be engineers, to choose to be pilots, to choose to be astronauts, because the jobs are there. And I don't know what happened. Young women, they're good in math, and for a lot of them, when they get in junior high, they start losing interest. And I hope you don't, because there's great jobs for engineers. It's a wonderful, wonderful creative career field, and we just need smart people, men and women. And it's cool to work with the guys. I love it. And they're supportive of you as long as you stay focused on the mission. Okay, how about maybe somebody from in the back, maybe the young lady back there with the standing up?
What was the part that you hate the most about going in space?
What do I hate the most about being in space, about going into space? Being away from my family. It's hard to say goodbye to my family. And my last mission, my children were age 4 and 9. And I have a way to deal with it. I mean, it's hard to go away saying, I'm not going to see, and I didn't see them for 5 weeks because we had 3 weeks in medical quarantine and then we had 2 weeks in space. So the way I deal with it is I say, okay, kids, I'm going to say goodbye, but we might scrub tonight and I might be back home. So that's just like my own personal psychology. We didn't scrub. So, okay, how about let's, anybody back in here there's a gentleman right here. You've raised his hand a couple times. I can repeat the question if you,
right.
Okay.
Please comment on the orbiting debris and its threat both to the space station and humanity.
Okay, his question was on, could you comment on the orbital debris and its threat to the space station and humanity? It is a threat.
Struck with orbital debris not too long ago.
Okay, I didn't know about that, but we had an astronaut that lost something on the last mission, and but that's important to talk about because we've had many astronauts lose things, and it turns out they're the most experienced astronauts, and there's things that we can do better, and so that's something that we recognize and we try to find ways to improve on that. But debris in space, we think of orbital debris as man-made stuff that either the satellite exploded because it was old and the tank overpressurized or something, or it was well, we had a satellite collision a couple weeks ago, which was terrible. It was in more of a polar orbit, one of them, and Chinese exploded something. I mean, you could go on, and there's been a lot of, let me just say it's a problem. Without going over everything that's happened, it is definitely a problem. The space station is hit by small pieces of debris. The space shuttle is hit by small pieces of debris. I photographed the space station mirror back in 1997. Solar arrays, cracks, holes from little tiny things that can't be tracked because they're so small. And the shuttle has been hitting the radiators, we're hitting the windows. We need to solve this problem. How do you clean up low Earth orbit, or Earth orbit period? Some of these things will be up there for thousands of years. The stuff down low will re-enter, but the stuff up high, it slowly comes down. So I just say put out a challenge to the international community, figure out a way, number one, to stop it. Maybe every satellite that's launched should have something on it to help deorbit it when its mission is over. Maybe we can improve our technology on what we're tracking. Maybe organizations, countries can talk to each other about where their stuff is, better space situational awareness. And I challenge, this sounds really far out, but figure out a way to clean it up. I can only think of expensive things that are, but there may be a cheap idea out there on how to clean up, because if a person gets hit on a spacewalk, it'll kill them. They'll lose pressure and there's not enough time to get back in. If the space shuttle gets hit in our heat exchanger, we have no chance because we lose our water and our freon cooling. If a window gets hit, we could lose all of our air. So it is the number one risk to the space shuttle in orbit is debris. Okay, I could go on that, but I won't. I won't belabor it too much, but it is a very serious problem. We've got a gentleman back there in the striped shirt. I can repeat the question if you like.
Hi, it's fascinating to meet you. My daughter's a senior, and she couldn't make it tonight because she's in night school. The question is relayed from her. How can you give her some advice to overcome her fear of geometry?
Fear of geometry?
Which is why she's in night school.
I would say, and this is what I tell my kids, we're all afraid of stuff. Everybody in here has a fear of something. And you learn about it. The only way I think that you can control fears is to learn about them. People often ask me if I'm afraid to launch on the space shuttle. I go, well, shoot, if I was afraid, I wouldn't go. But the reason I'm not afraid to go is I have studied everything I possibly can about how it works and then options on how to get out of bad situations. So she can't just avoid it. You've got to study it. I mean, keep studying. You can get extra help. Don't be afraid to go back and ask the teacher for some help. But that's how you fear of anything. Learn about it. Conquer it.
We have time for one or two more questions.
And I say, can I say one other thing about the math? I was not necessarily, I used to teach math, and I think I was a good math teacher because I was never really smart in math. I had to study it. I really had to study it to understand it. So I think that helped me be a better teacher because I maybe can empathize with how hard it is sometimes. Okay, so we had one more question. I don't know, can somebody else pick? I hate to pick the last person, but who had their hand up? Somebody had their hand up many times. Somebody over in here this gentleman had his hand up quite a few times. Okay, sorry, I'm not overlooking you.
Compliment you on being such a becoming-looking astronaut.
Oh, well, gee, thanks. I'm dealing with the aging process here.
Knowing how much my wife would have to pack to go on a tour.
Oh, that is a good question to end on.
What do very becoming astronauts, female astronauts, sacrifice when they go on a 2-week trip?
Okay, what was the question? I'm not sure I understand.
I didn't want to come right out and say it. What do you pack for 2 weeks?
Okay, we don't pack, actually. NASA packs for us. And as the years go by, there is less and less things that you can take up in space. So his question is on what do you pack? It's kind of a human interest question. I could hit this from any different angle. There's things that you have to take, clothes, for example. And so you take clothes up, and you only get like 5 shirts for a 10-day mission, so you have to improvise with what you have. Because there's so little that you can take. If you're a space station astronaut who's up there for 6 months, they get 1 shirt every 10 days. You have to deal with that. You just can't pack a shirt, and there's no laundry up there, so you have to somehow deal with that.
As a woman, do you take fingernail polish?
Oh, no. Oh, I see your real question. No, actually, that's a good question. We don't, because fingernail polish or anything with alcohol in it or any kind of chemicals, absolutely not. Don't even bother with stuff like that. It's a camping trip. Forget the jewelry, forget the makeup, we don't do that stuff. You do take toothpaste. I mean, there's basic human, yes, we do wash our hair, which is it is wonderful. They use it in nursing homes. It's no rinse shampoo. You have a hose, you squirt some water in there, get the shampoo, put that in, dry it in front of a science experiment, which is your hot air hair dryer, and poof, it's beautiful. And then, it really is beautiful. I say spaces, your face fills up, your legs get skinny, you have nice red color in your face, and your skin is not... It really is a great beauty solution. So if somehow you could pack it, it would be worth a fortune. And then you come back to Earth and it all sags again. Your hair goes down, your wrinkles come back, and you have to deal with all the things. But it is nice. You don't have to deal with makeup and hair and jewelry. You don't deal with any of that. You don't have time. It's just lipstick. No, it's just a waste of time. So you're on a camping trip, and you do the mission. Everything is the mission, and don't deal with stuff that's going to distract you from that. We're really good about that. So thank you so much for being a great audience, great questions, and you're actually easy on